All right. 4.4, the other trig functions. So everything that we've graphed so far has just been sine or cosine. So now let's take a look at graphing the other 4 trig functions. Okay, so number 1 there says graph y equals 3 tangent of x for 1 cycle. Okay, so remember when we talk about amplitude and period, that for tangent and cotangent, it's a little bit different. So there is no amplitude for tangent. So make sure when you list it out, there is no amplitude. The period now is now pi over b. Okay, well, here's my b value of 1. So this guy's period is just pi. Okay, so I'm still going to put some numbers here because this guy's 0 and this guy's 3 and -3. So he's still being stretched a little bit. 0, pi, and now we're only going to graph 3 points because tangent and cotangent don't have as much going on. All right, so 0 plus 1 is 1, cut it in half is just pi over 2. Okay, now, how do we know how to graph tangent? Tangent, I remember, has an a in the middle. Asymptote starts with a, so tangent has an asymptote in the middle. And then he starts at 0, and he goes up towards my asymptote, and he starts at pi, and he goes down towards my asymptote. He kind of does this, like that. All right. So graph y equals 1/2 of cotangent of 2x for 1 cycle. Again, there is no amplitude. Period is now pi over b, so pi over 2. 0, still labeling a half, and -1/2. 0, pi over 2. Half of pi over 2 is pi over 4. Okay, now, cotangent has an O in the middle, so I'm going to think about it as 0. So he's going to be here. So he's going to be a asymptote sandwich. And cotangent goes in the opposite direction. So he starts high and goes down towards my asymptote. Okay, so here's important things about tangent and cotangent. So for y equals a tangent of bx plus c, and y equals a cotangent of bx plus c, the amplitude is none. It doesn't have one. The period is pi over b, and the phase shift is still -c over b. So, can you find the period and sketch the graph of a tangent function? Can you find the period and sketch the graph of a cotangent function? We just did that for both of them. All right, number 3 says graph y equals 4 cosecant of x for 1 cycle. Again, there's no amplitude for cosecant. But now we're talking about the sine's reciprocal cosecant. So we're back to 2 pi over b. All right, so 2 pi over 1, so 2 pi. All right, now this guy's a little bit more important when we talk about these numbers on the y-axis. So we're going to label that at 4 and -4. And we're going to go back to labeling our 5 points. So 2 pi, pi, half of pi is pi over 2. 1 plus 2 is 3, can't cut it in half, so I'm going to double my denominator, so 3 pi over 2. All right, now, there's a little bit of work that has to go into graphing cosecant. Cosecant's reciprocal is sine, so I'm going to sketch in the graph of sine. So, there's sine. Now, where that sine crosses the x-axis, I'm going to graph an asymptote. Asymptote, asymptote, asymptote. And then I'm going to take its high point and I'm going to flip it over. So this guy is a parabola facing up and a parabola facing down. So he looks like that. You can go back in and you can delete or erase all of that orange stuff. Hey, eraser, stay on erasing. Every time I pick it up, it stops erasing. So really that green stuff, the green part is just our graph. Okay, so 4. 1/3 secant of 2x for one cycle. Amplitude is, ooh, I almost messed it up. It's none, right? Period. 2 pi over 2, so pi. Zero, 1/3, negative 1/3, 0, pi. Half of pi is pi over 2, pi over 4. If you know your fractions, that's 3 pi over 4. This guy is pi over 2 plus 2 pi over 2. So 3 pi over 2. I can't half the top, so I'm going to double the bottom. 3 pi over 4. Again, I'm going to sketch in its reciprocal. So secant's reciprocal is cosine. So cosine starts up, 0, down, 0, up. And then everywhere my cosine graph touches the x-axis, I'm going to put in an asymptote. And then I flip it over. Low points become high points become low points. And my graphs are a little close together. And then you can go in and erase. Oh, don't erase you stinker. All right, so he was there. Come on, buddy. Like that. So the graph is the green part. Whoa. There. So, for y equals a secant of bx plus c and y equals a cosecant of bx plus c, the amplitude is still none. Your period is still 2 pi over b, and your phase shift is negative c over b. All right, so here's one where we're putting it all together. So, number 5 there says, graph -1 minus 3 cosecant of pi over 2x plus 3 pi over 4 for one cycle. All right, there's lots going on for this guy. All right, so my amplitude is none. So here's A, here's B, here's C. I'm going to work over here. So my period, 2 pi over pi over 2. So 2 pi times 2 over pi. So my period is 4. Phase shift, negative c, negative 3 pi over 4 times negative c over b, pi over 2. So negative 3 pi over 4 times 2 over pi. So negative 6/4 or negative 3/2. All right, my endpoint. 4 plus negative 3/2. So that's 8/2, so 5/2. Vertical translation, that's this guy. So he's going down 1. Okay, so here's what we got going on. Down 1. That means this guy's negative 1. My A value is going to help me find these two values here. So negative 1 plus 3. That would be 2. Negative 1 minus 3 more would be negative 4. Negative 3/2, positive 5/2. Halfway in between, halfway in between, halfway in between. Okay, negative 3 plus 5 is 2. I can cut 2 in half, so that's 1/2. make sure I did that right. Negative 3 plus 5 is 2. So that's negative 1/2. No. Negative 3 plus 5 is 2. Cut in half is 1. Yes. Okay. Negative 3 plus 1 is negative 2. Cut negative 2 in half is negative 1/2. Yeah. Okay. 1 plus 5 is 6. Cut it in half is 3/2. Yes. Okay, now there's a few more things going on. This guy is negative cosecant. So I'm going to sketch in a negative sine graph. I'm going to do it in orange. So negative sine, like this. Okay. Everywhere it crosses the x-axis, I'm going to put in an asymptote, 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 and then flip him over. So that guy had a vertical translation, a horizontal translation, a negative. Ooh, you silly thing. Go here. He's like that. Like that. All right. So, can you find the period and sketch a graph of a secant function? Sure can. Can you find the period and sketch the graph of a cosecant function? Sure can. So the period of y equals tangent of b of x is just pi over b. And the graph of k plus a cosecant of bx plus c. First sketch the graph of the corresponding sine function to use as a guide.